Hey guys, welcome back to Data Mining and Predictive Analytics. I'm Dr. Bolton, and in this video I want to pick back up where we left off talking about data management systems. So if you remember last time we left off talking about the different schemas for a database management system and how one of the most important things of using a database management system is to keep the independence of logical and physical data. And so this allows us to protect both those logical and physical data schemas from our end users. So users and applications that are sitting on top of a database don't necessarily need to make changes to the logic or the physical schemas. All right, we can leave that up to the database creators. All right, and so for the most part, our users or our applications that are sitting on top of the database are going to be creating query transactions. All right, and that's how they're going to actually access or send and receive information from our database systems. All right, and so queries that they might be interested in actually looking at. So imagine we had a university database system. Maybe they're interested in knowing what the name of the student is with an ID of 43. All right, or what the salary of Professor Kevin Smith is. Or they may want to know how many students are actually enrolled in Introduction to Database Management. All right, so these are just some of the simple queries that you might be able to make in a transaction to a database system. All right, some of the more advanced queries might be something like how many students are enrolled in the database management system that actually received a grade less than a C. So you can even make more complex transactions through these queries as well. All right. So the way that we build queries is using a scripting language called SQL, or most familiar to me, and what I'll probably call it is a SQL query. All right, this allows us to be able to create transactions, and it's probably the most common language that's used for relational databases. All right, we're going to talk a lot more about this in the next several upcoming videos, and so I won't dwell on this too more, but some of the most simple commands that we can use in a SQL language is things like create, which will allow us to create tables within our SQL structure or database. Insert, select, update, and delete are all other commands. SQL stands for Structured Query Language. So you've heard me use this term, relational database management systems. All right, this slide, I just go a little bit further in detail about what some of the examples are of these types of database management systems. But it's basically a set of software tools that controls the way that we access, organize, and store data. All right. Some of the examples of these database management systems are like MySQL, Oracle. All right, DB2 is a big one. And AWS. These are all examples of different database management systems that you can use. So a lot of different options out there for being able to create a database system, and a lot of different platforms from which we can do this on. But all of these platforms basically use the same setup or the same principle for being able to create a database. And that's what I want to talk to you guys about today. So there's basically in the life cycle of actually creating a database, three different phases that I want you guys to be familiar with. Phase one is developing what are the requirements for building your database system. So these usually come from your customer, all right, your user, your company, all right, and it's an application that can be built upon bank, travel, reservation systems, social network. But you basically need to decide what you're going to technically design in the database. All right. In phase two, all right, you're going to develop a conceptual database design, and we're going to talk a lot about ER diagrams here in the next few slides. But this is basically where the database designer sits down on paper and decides what the database should look like. All right. Using these entry relationship model diagrams, or ER diagrams, you're going to build a representation of what the actual database was going to look like. And then in phase three, we actually create the logical database design and convert that ER diagram into a relational database schema. All right. So this might, so physically this looks like, this is a little visual representation of what that actually might look like. You're going to see a lot of these flow diagrams either in the textbook, all right, or in the next few slides. But in phase one, we're really identifying what the problem is and coming up with a conceptual data model, all right? And so going through analyzing the requirements, developing that preliminary model, all right? And then taking those initial requirements, and this is what we call phase one, where we identify the problem. And so this requires us to get the requirements, which involves either interviews or meetings with the company executives, your end users, to understand what the function of the database is going to be, what objects, what entities are going to exist, all right? So what are the company's data entities, all right? What are the tables that you're going to create in this relational database? What are the attributes that each of the entities are going to have, and what are they going to, how are they going to be associated with the entities? And then what are the major relationships between the entities that you need to know about, and are the relationships between different attributes of interest? And so these are required. These are important when you're trying to develop the requirements for your database system. All right. In phase two, you now take those initial requirements and then develop an initial prototype. All right, this is where you're going to actually go in and develop your ER diagram. All right, create that logical database design and your physical database requirements for the definitions. All right, and then from that ER diagram, you may develop an initial prototype. All right, which allows us to go on into implementing this initial prototype, all right? If there are problems with that prototype that we need to address, or things that we need to deal with, we may go back and create revisions or enhance the prototype and come up with a new version. So this becomes kind of a cyclic process here, all right? And it's only in phase three that we then move on to convert this into an operational system. But for now, I'm going to talk a little bit more about the phase two part of this, developing that initial prototype using these ER models, these entry relationship diagrams. So again, phase two involves the preliminary data model, all right, and creating these ER diagrams. And so here we see a simple ER diagram for, say, a company that has customers and orders and invoices from a product. This could be anything like, I don't know, Amazon. Think about that, where we have a simple ER model diagram. Now I'm going to explain these relationships and what this type of model is, but basically I can just look at this ER diagram and tell you that here each customer places any number of orders, all right, and conversely each order is placed by exactly one customer, all right. Also, each order contains any number of order lines, and conversely each order line is contained in exactly only one order. So this is just some of the examples of what an ER diagram. But let's look a little bit more closely at what each of these are. So an entity is a real-world object. We talked a little bit about this, and can be distinguished between other objects. An entity is described using any number set of attributes. All right, so think of your table. The table is the entity. All right, those columns are the attributes in your table. All right. Each of those entities can have what we call a key. So each entity has a set that has a key. And this is usually a unique identifier in some kind of way. All right, so if I have an example here where I have a number of employees, all right, is my entity, and each of my attributes for the employees is that they have maybe a social security number, all right, they maybe have a name, whatever a lot is. So these are just different attributes, all right. But I have to assign a key to one of these attributes, and that's the unique identifier that is going to allow me to be able to identify each of the rows for that entity. So that needs to be a unique identifier. Oftentimes you just assign attributes keys. The primary key is assigned like an ID, like you would have an employee ID number, right? Which would be like 1, 2, 3, 4, 5, right? But they can also be an attribute that is unique in itself. So we all know that a social security number is unique to an individual and therefore should not be the same across any one of our employees. And so here I can just say, hey, I'm going to use the social security number as that unique identifier. That becomes the key for my employee entity. All right. Each attribute is going to have an actual domain. All a domain is what is the data type? What is the domain of the value? What value can that attribute have? All right. So is it going to be a string, like in the name attribute, or is it going to be numeric, as in the social security number attribute? All right. And so each of those is going to have a domain. All that is the data type for which attribute and what those values can be. All right. I've also put up on Blackboard a nice little cheat sheet for you guys. It talks a lot about the crow feet model that we're going to be talking about. All right, and the relationships between entities. Microsoft Visio Pro, if you have access to that, is also a great tool for being able to create database diagramming for modeling these ER relationship models. All right. So here we're using an entity, an ER model. All right. Like I said, we've talked about entities. We've talked about attributes. Now we're going to talk about relationships. Relationships are associations among two or more entities. All right. And this is just an example of what a relationship might look like between two particular entities. All right. And so oftentimes we use verbs or adjectives to be able to help describe what is the relationship between the two entities. All right. And so here we have an example of the employee entity is assigned to a parking space entity. All right. For example, Alice, who is in our employee table, our employee entity, is assigned to the parking space 1, 2, 3, 4. All right. So there is that relationship between Alice and her parking spot. All right. The same thing between student and courses. All right. Here we have a student entity, and it's registered, and each student is registered for a course. All right. We're going to talk a little bit more about these constraints and what these mean. Why this looks like it has this little 3 legs, or what we call crow's feet, coming off of here. These are the different constraints on the relationship. So you can have a one-to-one constraint between these two entities and the relationship. So an employee can only have one parking spot. A parking spot can only have one employee. All right. Whereas down here, a student can be registered for many. That's what the crow's feet means, many. All right. So a student can be registered to many courses, whereas a course can have many students as well. All right, so you can read both of these this relationship back and forth between both entities. All right, and whereas a product line contains many products, all right, a product can only be on one product line. Okay, and so that's kind of how you read that. All right, and in our example for student and courses. All right, if we had a student named Kevin in our student entity, our student table, that student could be registered for many courses such as BMN 411 or iTech 590. All right, and so this is how you read or design these ER diagrams between different entities, and you can only While here I'm just showing the relationship between two entities. You can actually have multiple entities and they can all have relationships with one another. All right. And so this can get pretty complex, but building the ER diagram makes your life so much easier when it comes to being able to then create your functional database. All right. Because then you just take the rules that you designed, all right, in your ER diagram, and then just convert those into your relational database, your functional database, and everything's set up. And so this is a key component for your life cycle for understanding how these relationships are developed. Again, I've added a little bit more detail, all right, on the actual cheat sheets that I have for you guys up on Blackboard, but I just wanted to have this here in the slides for you here to look at the constraints, all right. There are definitely several different, if you go and you search the internet for the different notations for being able to do ER diagrams and describe these relationships between entities, you'll find a lot of different ways to notate this in an ER diagram. We're using the crow's foot notation here, or what is called Baker's notation, to describe the relationships between entities. Sometimes you'll see these relationships have these diamond shapes, and so the relationships will be inside of these diamond shapes, and your entities will be in rectangular or square blocks here. All right, and so if this is the relationship, all right, the relationship between this entity is, if you see the double lines here, is a mandatory. If you see a single line with the crow's feet, is mandatory. They have many. All right, then you have optional. All right, with the little open hole, open circle here. All right, or optional mini. All right. This is also an example here, just on the right hand side, of how you could have several different entities, and all those entities can have relationships among one another. Okay. And so take a look at that. Again, I've got some cheat sheets up there for ER diagrams, which can be found up on Blackboard. Okay. This slide just talks about weak entities here, and a weak entity can be identified uniquely only by considering the primary key of another. So remember, I told you that there are keys for relationships. So you have to give each entity a primary key. All right, but some entities, some tables will only exist because of another entity. All right. In this case, all right, it's what is called a weak entity. So take this example that I have here, where you have an employee. All right. Maybe there's an employee entity with social security or number, name, lot, whatever. And then you have another entity of that employee's dependents. All right. Think about wife, husband, children, whatever the dependents are. All right. Well, those dependents wouldn't exist in this database if it was not for this person in the employees table. All right. In other words, if Dr. Bolton wasn't an employee of the University of South Carolina, therefore there wouldn't be any dependents for there to be an insurance policy for with USC. I know that's very vague. But again, this is what we call a weak entity. The dependence entity is a weak entity because it doesn't exist unless there is an employee for it to exist upon, for that relationship to exist. All right. Oftentimes in an ER diagram, if you have a weak entity, it's usually outlined by a double-lined box or a double-lined entity square. All right. And if it's a weak relationship, which is the case here for the policy, the insurance policy, that will be a double-lined diamond as well. All right. So just understand that there are weak entities out there. The textbook actually goes through a lot of this stuff in greater detail. In fact, ER diagrams are such a big thing in database development. or the life cycle of creating a database. That the textbook that we have, which is also on Blackboard, actually dedicates almost 3 chapters to ER diagrams. All right, so just giving you guys a little taste here. But if you're interested in more about that, check out the textbook. Also, part of phase 2 is being able to identify those attributes for the entities. And so here in this slide, and in fact in chapter 2, I believe it is, it goes into a pretty good discussion about how to identify whether to create an entity or an attribute for an entity. All right, because oftentimes it's difficult to know whether or not you actually have an attribute for an entity or an entity itself. All right, so but it's important to identify what those attributes are going to be. Right, so say you have a customer. The customer is obviously going to have some kind of name. Maybe they have an address, a zip code. If you have products, you have a product identifier, maybe the description of the product, some cost associated with it. All right, if you have an order, you might have an order number, fulfillment dates, all these kind of things associated with a particular order. Same thing with an invoice. So these are just some examples of the attributes that are associated with these different entities. All right, so once you've identified what those are, you can then go on to create your more complex model and add those attributes to your ER diagram. And so this is what a kind of fully thought out description of what a prototype ER model might look like, in which we have our customer entity. All right, we've identified what the primary key is going to be in the bold, all right, numbers. So we know that our primary key here is going to be our customer ID. That's going to be an automated generated value. All right, and then there are all these other attributes that are associated with the customer as well. All right, for the order, all right, the primary key for the order entity is an order number. All right, the placement date, the fulfillment date, all of these values that are associated with the actual order. All right, and we know that there is a relationship between the customer and the order. So an order, so a customer, just looking at this relationship and the crow's feet model that is describing the relationship between these two entities, we know that a customer can place many orders, all right, but an order can only have one customer. All right, so that's how I read that relationship between the customer entity and the order entity. All right, and so it might be good to just go through the textbook, look at a lot of these different ER models, these ER diagrams, and see if you can look at those diagrams and tell, all right, what is the relationship between those entities? What exists? Is it a multiple entity or a relationship? All right, is it a many relationship? Is it a many-to-many relationship? Is it a one-to-many relationship? So I would get in the practice of doing that. All right. The next thing to do is that once you've kind of built your prototype, you need to implement and use this prototype to really understand, is this working for it? Are we identifying all of the entities and all the attributes? Are we capturing all the data that we need to and meeting all the requirements that we identified back in phase 1? All right. If we're not, all right, we need to go back and revise and enhance that particular prototype. All right, we need to make any new adjustments. Are there new requirements that have come out by our user? All right, and then come up with that next version. All right, and implement that and see if we meet all the requirements. If we meet all the requirements for our user, all right, then we can go on and push that and convert that into a functional operational system. All right, and once we've converted that into an operational system, our now new requirements are database maintenance. And so now we need to tune the database, optimize the database, fix any errors that we're having within the database system, understanding what views may be important for different users, creating new user views, new external schemas, all of that kind of stuff for our operational system. All right. And so in phase 3, we translate the data model that we created, our prototype, our ER diagram, into that functional database. And here we just see a screenshot that I took out of, I forget which database management system I was using. But this allows us to be able to see all of the tables, all of the entities, all right, all of the attributes, and as they're being populated within the data tables, all right. And now I can go back, I can create my SQL queries, all right, and I can and I can create query transactions against the database to be able to extract information from these tables, from these relationships, and populate my views for the data that I want to see. Take those views, export that into some other system in which I can do more complex data analysis on. So hopefully this explains a little bit of information about database management systems, all right, how we go on to create a database model, all right, and then get our ER prototype, and then convert that into a functional database system that we can now produce SQL transcript or SQL transactions against. All right. If you have any questions, email me. Feel free to check out the cheat sheets that I put up on Blackboard for you guys. Also, the textbook database management systems, modern database management systems, is actually on Blackboard as well. Take a look at the first 3 chapters if you're really interested into learning more and diving more deeply into these ER diagrams. That's all I got for you guys today. Thank you. Have a great day.